So like we said, at 0, it was 0 for tangent. So that would be a point right here. Now you also would notice from the unit circle, at pi, it also came out to 0. So every pi unit that you go down, the cycle repeats. So there'd be one here. There'd be a point over here. There would be a point over here. Right? These would all be the center points. Now, how do we get the other points? So if you kind of thought of this 45-degree angle, which is pi over 4, right? It's halfway to pi over 2. So it would be falling in this column here. That, on the unit circle, that coordinate would be root 2 over 2 and root 2 over 2. But the tangent of that, you'd be dividing root 2 over 2 divided by root 2 over 2. The tangent would equal 1 at that place. So that would be here. So we call that like a quarter step kind of thing. It's halfway between the center and your asymptote. So it's typically up 1 over 1 unless there's a transformation. Now we could also go negative 45 degrees, and that tangent would be negative 1. So that coordinate would be down here. That's basically it. It's like 3 points diagonal in a row. Now you're not going to draw a straight line here because as you get closer to pi over 4, you're never technically going to touch that line. And the same thing going down here. And that's going to be true for every chunk of this. So from the center, you're going to go up 1 over 1, down 1 over 1, and show your curve getting very close to that asymptote. And it looks the same in every column, it looks like. So there we just graphed 4 cycles of tangent, right? And it gets easier the more you do it. To me, actually, tangent becomes the easiest one to graph after I practiced a few times. Here's all the transformations. You can write it on the next slide. I'll put a screenshot of this on the next slide, so don't worry about that right now. But it's very similar to the sine and cosine transformations. The A, the number in front, is similar to the amplitude. Now, technically, there is no amplitude because it goes on forever vertically, right? So we can't judge height when it goes on forever. But it's similar to that because that will give you a vertical stretch on those quarter points like we were just talking about. You know how I said you go up 1 over 1 and down 1 over 1? So if that was like a 2, you'd go up 2 over 1. You know what I'm saying? The period is typically just pi, right? But if there's a number between the tangent and the x, the period would be pi divided by that number, right? And remember, period is how often the cycle repeats. The c over here is your horizontal, just like with cosine and sine. It's how far right or left you shift. And then at the end, whatever's being added or subtracted, that is your vertical shift. So the weird part is going to be the domain and range. Domain is going to be all real numbers except for all those asymptotes. So the way you're going to write where one of the asymptotes falls, which typically is at pi over 2, plus a period. So a period on a typical tangent is pi, right? But they put this k in front of it, and it says where k is an integer, meaning you can add infinite cycles of pi to this, and that would give you the equation for all your asymptotes. We're basically going to be writing the same thing every time for the domain. Range, which is your y values, that is unlimited, right? So that's all real numbers. So I believe we have 2 that we're going to try out. I'll just wait until the next video and we'll try to do both of them in the next one.